arithmetic sequences and series. In our previous lesson, we just talked about sequences. And that's what our first bullet point is here. It says, suppose that n is a natural number, and we have a sub 1, comma, a sub 2, comma, a sub 3, comma, dot, dot, dot to a sub n. All that is it's a list of terms in a certain order. And that is called a sequence. What's new for us today is if we take that list of terms and instead of writing it with a comma, we write it with a bunch of pluses. A sub 1 plus a sub 2 plus a sub 3 plus dot 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 a sub n. When we add them all together, because sub means the answer to an addition problem, this is called a series. And we have a formula for adding them all together. The abbreviation for adding them all together is S sub n. The n is like an exponent, only we drop it down instead of move it up. S sub n is called the sum of the series. So to summarize, it says, what is the difference between a sequence and a series? A series is a list of terms that are added together. Sequence, it's just a list of terms. The series, they have to be added together. So what we talked about, like I said earlier, in our earlier lesson, is it says the arithmetic sequence review. A sequence. It's an ordered list of numbers in which the difference between each number and the one before it is constant. In fact, if we want to get more specific here, an arithmetic sequence, they're expressed in the form of a sub 1, comma, a sub 2, comma, a sub 3, comma, dot, 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 a sub n. Each value in the sequence is called a term. We have a common difference. A sub n is the nth term, and we can find it by using this formula here. A sub n equals a sub 1 plus n minus 1 times d. That formula will be provided to you on a quiz and or test. But let's look at an example of what we were talking about on Friday. It says find the 100th term of the arithmetic sequence and start left on your paper to, if you want to list out everything that we know. Because the formula that we're going to use is the one that we were just working with, or that we just looked at, is the a sub n equals a sub 1 plus n minus 1 times d. And what we know from our information given here from this particular sequence is that a sub 1 equals 5. And it says find the 100th term. That means that n is 100. We need one other piece of information, and that is the common difference. And to figure out what the common difference is, what we do is we take 8 minus 5, which is 3. 11 minus 8, which is 3. 14 minus 11 is 3. Is 17 minus 14 3? Yes. So our common difference here is 3. And now that we know that information, we can put that back into our formula to find what the 100th term is in here. A sub 1 is 5. The 100th term, there's our n, minus 1, times d, our common difference, we just figured that out, is 3. So this is going to give us the 100th term. The nice thing is, if you want to, you can take your calculator and you can type it in. 5 plus parentheses 100 minus 1 times 3. And we get 302. Otherwise, I oftentimes calculate that by hand. But why not use your calculator if you have it? It's a straightforward type it in. Now, what we just began today is talking about an arithmetic series. And again, a series means that we're adding something together. Sum. The sum is the answer to an addition problem. So it's the sum of the terms in the arithmetic sequence. And if we take the example that we were just given here, which was 5, 8, 11, 14, 17, we can write it as a series simply by saying this is 5 plus 8 plus 11 plus 14 plus 17. There's an example of an arithmetic series. Those values are added together. Instead of adding each term in an arithmetic series, we can take the sum by using this formula. Again, S, for the sum of n terms, is n divided by 2 times the quantity of the first term plus the nth term. So if we look at, in particular, what these parts represent, S sub n, it's the sum of n terms. A sub 1 is still our first term. A sub n is our nth term. And I didn't know exactly how to fill in n, but it's the term that we're looking for, the number of terms that we're looking for. So I put number of terms. And let's try a quick example here to see how that. Use a formula to find the sum of the first 15 terms of the series. 2 plus 10 plus 18 plus 26. And go left. Even if you have to go across that line on your paper, go as far left as you can, because there is, you need the space. But if we take a look at what information we know here in this particular problem, well, we know that A sub 1 is 2. And we can figure out our common difference. And the way that we do this, and I'm going to erase this because I need the space as well, but the way to find the common difference, especially for people who were absent last class, is we take 10 minus 2 is 8. And 18 minus 10 is 8. And 26 minus 18 is 8. The 8s all have to be the same for us to have a common difference. There's our common difference of 8. It says, use the formula to find the sum of the first 15 terms. But as we look at this formula here that's above on your paper, the S sub n equals n divided by 2 times A sub 1 plus A sub n, what we don't know in this problem is we don't know what A sub n, in this case A sub 15, equals. And that's why I said go left on this paper so that you have enough space. When we start this, we need to go back to what we did on the left side of our paper, which is use this formula, the a sub n equals a sub 1 plus n minus 1 times d. What we're looking for at first is we need to figure out, well, what does a sub 15 equal? Well, a sub 1 is 2. Our n is 15, and our common difference is 8. And like I said, we can take this problem, if we need to, and we can type it in. 2 plus, parentheses, 15 minus 1, parentheses, times 8. That gives us our value. We just straight typed it into our calculator. So a sub 15 equals 114. But what we really want to know now is what's the sum of all of those. And our sum formula is S sub n equals n divided by 2 times a sub 1 plus a sub n. So let's fill that in, and hopefully you've got enough space to the right of your paper. We know that n is 15. Our a sub 1, we knew that already. And we just found our a sub n, in this case, which is going to be a sub 15. I'll write on top of that. It is 114. And again, we can type this into our calculator. Your fraction button, alpha y equals 15 over 2 times a sub 1, which is 2, plus the 114, gives us our value here of 870. Equals 870. So that's S 15. The thing about the sum formula is that we oftentimes have to go backwards and figure out a term before we can use it. But as we turn our page here, use the given arithmetic sequence to complete the following. We want to write the nth term formula, like we did last class. And then we want to figure out what the 17th term is. So the nth term formula is that first formula up there. A sub n equals a sub 1 plus n minus 1 times d. So let's list what we know here, and I think that you do have enough space to put this off to the side. But our first value, a sub 1, is the first number in our list of terms, which is 26. We can figure out our common difference, and the way we do that is we take 13 minus 26, 0 minus 13, negative 13 minus 0. And every single time that we type that in, we get negative 13. And that's our common difference. That's all that we know to put back in our formula. And we're just coming up with the generic formula for this. So a sub 1 is 26. We don't know n. But we do know that our d is negative 13, and be careful because our common difference is a negative number. So we've got to watch out for the signs on this one. So it's a sub n equals. So we get 26 plus negative 13 times n And negative 13 times negative 1 is positive 13. Be careful because that negative got caught up there in my plus. It's negative 13n. And I got 26 plus negative 13n. But if we combine like terms here, and I can write better, we get 39 minus 13n. I don't know why. I just wrote plus a negative. Negative 13 times n is negative 13n, and I had written that plus already. So a sub n equals 39 minus 13n. And once we know that formula, when we want to figure out the 17th term over here, all that we're going to do is we're going to put 17 back into our formula, and we'll type it in our calculator. 39 minus 13 times 17. What do we get? Negative 182. That's our 17th term. We don't have to find the sum on this one. We just had to find that term. So if we kept going, negative 26, 13, 0, negative 13, negative 26, negative 39, and so forth, eventually we're going to get to negative 182. Number 2, find the first term of the arithmetic sequence if the ninth term is 72 and the common difference is 5. I'm so glad that I put this problem on here. It's one of my favorite types. And the thing is, it says, find the first term. Well, we don't know what the first term is. What other information do we have? We know that the ninth term is 72. And we also know the common difference is 5. And from the information that we wrote down, we know one more thing. And that one more thing is the n. Do you know what n is? Well, it's 9. Came from this 9 right here. Well, our formula that we want to use, because we're finding the first term, so our first equation is the term, is a sub n equals a sub 1 plus n minus 1 times d. And we have enough information now to fill in the rest and help us solve. A sub n happens to be the a sub 9, which is 72. We don't know. A sub 1, that's what we're going to try to find, plus n, well, 9 minus 1 times d, our common difference of 5. When we simplify, we get 72 equals a sub 1 plus 8 times 5. 9 minus 1 is 8. And 8 times 5 is 40. And therefore, to figure out what a sub 1 equals, we can subtract 40. And we get 32 equals a sub 1. And there's our first term. So problem number 3, it looks remarkably similar to problem number 2. It looks like we're going to be able to go right about our business and solve this equation. And start left on the paper. We're given some of this stuff, but it says, what is n on this one? We're given a sub 1 is 3, a sub 5 is 19, a sub n is 163. We want to know what n is. So we go back to our first formula, the a sub n equals a sub 1 plus n minus 1 times d. And let's fill in what we know. Well, we know a sub n is 163. We know a sub 1 is 3. But we don't know what n is. And we don't know what d is. And because of that, we need to ask ourselves, well, why did the problem give us a sub 5 equals 19? So beside it here, I'm going to say that let's use that a sub 5. So let's look at some other information that we're given in this particular problem. And what we know is we do know that a sub 1 is 3. That's important. We know that a sub 5 equals 19. And implied in that is the fact there's the 5. And consequently, what that means is that n equals 5. And we're going to have to go back and use that information to help us determine what the common difference is. So same formula, the a sub n equals a sub 1 plus n minus 1 times d. But in terms of our information here, we've got a sub n, which is going to be the 5, a sub 5, which is 19, equals 3 plus 5 minus 1 times d. This is going to help us find the common difference. And then once we find that common difference, we're going to use it back in our formula from before. So we have 19 equals 3 plus 4d. Still solving this equation, we're going to subtract 3 from both sides. And we get 16 equals 4b. And then we can divide both sides by 4. And b equals 4. I'm going to take that value and put it back in here for the d. So the other stuff stays. We've got 163 equals 3 plus n minus 1. Now we're going to fill in d. We just found out that d is 4. And we're going to let that help us finally figure out the value of n. I'm really sorry. I don't think I left you enough space. You're probably cramming it in at this point. I'm really sorry. You get 163 equals 3 plus 4n minus 4. Combine like terms over there on the right side. So we have 3 minus 4 here, which is negative 1. Plus 4n. We're close. Some of you are even ahead of me. We can add 1 to both sides. We get 164 equals 4n. And finally, when we divide 4 times n, when we undo that operation, divide by 4, we get 41. So far, we haven't done any problems that have had a sum in them. But here comes the sum. Find S sub n for the arithmetic series where a sub 1 is 16, a sub 13 is 98, and n equals 13. Well, we have everything listed. We don't often get so lucky to be able to go immediately into this formula and fill in what we know. N is 13. a sub 1 is 16, and a sub 13 is 98. But do let me take this moment to point out, a sub 13 is 98, and n is 13. That's the a sub n. And if you can get the problem set up, then we can type it in. Remember our fraction button. Alpha y equals, number 1, 13 divided by 2, parentheses, and then it's going to be 16 plus the 98, and enter. So that equals 741. But remember, we aren't always so lucky. Sometimes we have to go back and use an old formula to figure out what that a sub n is. And I think that happens here on example number 5. Find the sum of the first 8 terms. So a couple things to watch out for. Here's that word sum. And consequently, that means we're going to have to use s sub n equals n divided by 2 times a sub 1 plus a sub n. Find the sum of the first 8 terms of this arithmetic series. And what we don't know in this problem is we don't know what a sub 8 equals. But we can figure it out. And actually on this one, it's not too tough. But on this one, we would use the formula a sub n equals a sub 1 plus n minus 1 times d. But if you were here for the last class period, what we can do is we know 2 plus 5 plus 8 plus 11 plus 14. This is A1, this is A2, this is A3, this is A4, this is A5. Can we figure out what A6, 7, and 8 are without using a formula? Because what's the common difference in this problem, even though we haven't written it down yet? 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. And what do we need to do to get these next 3 values? We need to add 3. 14 plus 3 is 17. 17 plus 3 is 20. 20 plus 3 is 23. We could use this formula, but I think that just looking at the problem gives you a little bit more leeway to figure out what it is. So I wrote down the formula, but now that we know that, we can figure out the rest here. And I should have written down a couple other things. The other things being the fact that a sub 1 is 2. We found our common difference. The difference is 3, but we don't need that over here. We know that a sub 8 now is 23, which means that our n is 8. And that gives you a little bit of space too, because now we can fill it in. 8 divided by 2 times 2 plus 23. And without typing that in the calculator here, it's 4 times 25, which is 100. You can type it in. I definitely want to at least get to 1, maybe 2 more examples. Number 6. Find the sum of the arithmetic series. We didn't have to do it on the last one, but we're going to have to do it on this one. It does say find the sum, so we need to watch out for that. So to the left of your paper, but I am going to write down what we know, but we're going to have to use s of n equals n divided by 2 times a1 plus an. And the thing is, we know what an equals, but we don't know what n equals. Like I said, so I'm going to have to do this. We are going to have to use this formula this time. And again, some of your faces are saying, no, I don't know why. But we know that a sub 1 is our first term listed, which is negative 4. And we know that a sub n is 91. So we know where we can put those. But we don't know what n is. We can figure out the common difference, which is 1 minus a negative 4, which is 5. It's 6 minus 1 is 5. 11 minus 6 is 5. There's our common difference. And we need that to figure out what n is so we can fill in the rest of it. Because we know these parts, like I said. We know negative 4 plus 91, but we don't know what n is. So we've got to figure that out. When we come over here, we can still use what we know. We know our a sub n is 91. And our a sub 1 is negative 4. I'm looking to the left on our paper. Plus n, we don't know n, but we do know our common difference. And we saw one of these on example number 3, if I remember correctly. So we get 91 equals negative 4 plus 5n minus 5. Combine like terms, and we get 91 equals negative 9 plus 5n. Move the negative 9 over to the left. So we'll add 9. And we get 100 equals 5n. And divide both sides by 5. I don't know why I changed colors there, but divide both sides by 5. And n equals 20. Well, now that we know that value, we're going to put the 20 in here so that we can find our sum. And once again, we can type this into our calculator. It's going to be alpha y equals, and by the way, I wouldn't really type it in because I know that 20 divided by 2 is 10. So some of you out there, if you're thinking about that, and then it's negative 4 plus 91. And that gives us our value of 870.